Okay, welcome back everyone. Last lecture we have reviewed some of the basic Python stuff. The Python you should know from the CS1. And today we will move on and we will review some of the content from the CS2. And CS2, I mean the data structure. In UNCW, it is CSC 231. And if you are from other institution, I believe you should have also taken the data structure, or you have already learned some data structure from the CSC 500 here. Okay, so before I start the review, I want to remind you one of the configuration you have to do with the PyCharm. You have to make sure that you install PyCharm and Python at first, and then you have to click on the config and settings, and after that there is a project interpreter. You have to make sure that there is something here. This means PyCharm is able to find the local Python you have installed on your local machine. Okay, as you can see, this is an old version of Python. The old version of PyCharm, the PyCharm from 2019, and I'm about to show you the new version of the Python, the new version of the PyCharm from 2020. Okay, so I just have installed that, and let me come back here. Okay, so you should see this page first. This is a place that you can create a new project. Okay, so you want to go to the customize and then all settings. Under the all settings, you will be able to find the Python interpreter, and as you can see, I don't have a default Python interpreter yet, and that's not right. Okay, so let's see how can we fix that. Click on this icon and then do add. Okay, so as you are doing this, and you need to make sure that Python has already been installed on your local machine, and for me, I know it is here. Okay, so you should be able to find the python.exe. Okay, and for me, I know python.exe is here, but for some reason I can't click OK yet. The problem is this PyCharm also requires you to create a environment directory, and it has to be empty. So let's say let me just create a new folder here. So Python working folder. Okay, so this is an empty folder because it doesn't exist. So I'm gonna PyCharm will create this folder for me, and then this will be a empty folder for now, and now I'm able to click on OK. And after that it will take a while, but after you have done this step, and then PyCharm will know where to find your local Python on your local machine. Okay, so I'm gonna leave it here, and then let's continue. For the data structure, the very first one I want to talk about, which is also a basic one, that is the list. In Python, we call that the list. And a more general name of this should be array. Okay, in Python, there's one really cool thing about the list. That is, we can put any data type into a list. Okay, so in Python, if you want to create a list, the first value is a number, and then the second value is a float number, and then the third value is a true, which is a boolean, and then the number 4 you have a string. So you have integer, float, and boolean and string. You put them all together into a Python list. It works. If Python is your first programming language, and you may find, okay, that's normal. However, if you come from C or C++ or Java, and this is something bizarre. Why? Because, the old school array, they require all the values to have the same data type. However, in Python, there's no such a requirement. So it seems that Python is better. And if we want to look inside into Python's design, and let's see how this can be done. Okay, in Python's list, in the memory, we have a header. So we have a header, and then there is a special area that we keep the length. That is, how many items do we have in the list. And after that, what do we have? We have an array of references. Okay, that is the tricky part. So the real in the Python list, it doesn't really store all the items in place. It stores an array of the references. So the first reference, well, it refers to an integer. The second reference, it refers to a float number. The third reference, it refers to a boolean, and the fourth one, it refers to a string. Well, now, here is the tricky part. Well, in the old school programming languages, for the arrays, they require all the items to be exactly the same data type so that for each of the cell, for each of the item, the size are the same. However, in Python, since we are doing an array of references, we are more flexible, and now we are able to put any data type into a Python list. Okay, so that's the tricky design about the Python list. I'm not saying it is good or bad, but this is a different design from the old school programming languages like C, C++, or Java. Okay, well, and what's the problem with this array-based design of Python list? So consider this. Well, let's say we have a Python list of 3 items. So we have the header, we have the length, and then we have 3 references. The first reference is to Paris, and then the second reference is to Alice, and the third reference is to Bob. Okay, so we have a list of 3 items. And consider this. Right after Bob, we have another object taken the rest of the memory. So what's the problem? The problem is if we want to add one more value into the list, now we have a little bit of trouble because the next slot we can possibly use has already been taken. Now, what do? We have to find a new memory space. So we are copying the existing list into the new memory space before we can add one more value, Charles. Okay, so it's kind of troublesome because if we have a list, it keeps on growing and growing and growing. Well, sooner or later, we may have this kind of issue because the next memory space cannot be claimed anymore, so we have to find a larger memory space, and then we have to move everything from the old list memory space to the new one. So this will be expensive. Okay, well, and then this brings us to the idea of the linked list. So for the linked list, well, the main design idea is we do not want to create a list using a continuous space. The problem with having a continuous space is, well, we have to find this space, and if we grow this list, grow out of the existing space, we have to find a new home, and then we have to do a big relocation. If we don't want to do that, now how about we just claim small pieces of the memory here and there, and then we are using references to link them together. So for each of the node, there are only 2 items, well, or only 2 fields. One is the field we are holding a value, and the second part is a reference we point to the next node. Okay, well, that is called a next to reference. Well, and I'm going to give you a linked list.py, and you can take a look on the full implementation. Okay, well, and this is example. Well, we start from a head. So this is the beginning of the linked list. And then the head points to the first node, and that is Paris. Well, the Paris has a next to reference and referring to the next node, which is Alice. And the Alice refers to Bob, and Bob refers to Charles, and then eventually Charles refers to nothing, which is a none in Python. So now we have a linked list. So why is linked list cool? Well, because we do not require a continuous space. Okay, and say if we want to add a new node, and we never need to do a major relocation because we just create another, we just claim a small memory space, and then we are just adding one more node to the linked list. Okay, well, let's take a quick look on the definition. Well, we are doing a class. Well, and we have talked about the object-oriented in the lecture 1, so you should know, well, how do we define a class? So we define a class called node, and then in the constructor, well, we have to put in the initial data, and that's the initial data for this node. Okay, well, we are going to assign the initial data to self.data, and then to begin with, we don't know where is the next reference, so we are doing the next dot equals none. Okay, and then we have the get data, we have the get next, we have the set data and set next. So those are the helper methods that we can use to get the current data or get the reference to the next node or stat the. Okay, well, and then we want to create another class linked list. Okay, for the linked list, well, to begin with, we have to set a head. So the head, by default, it should refer to the first node. But if we have an empty linked list for now, and then the head will point to a none, saying, okay, I am a linked list. However, my head is pointing to nothing, so there's really no node in the linked list for now. And then we have a is empty, so we check whether the self.head is a none. If it is a none, and this means even though we have a linked list, but there's no even the first node yet, so it is empty. Otherwise, it's not. And then we have an add. So for the add, we are adding one more value into our linked list. And how do we do that? Well, for the add, we do have an item that is a value, the new value we want to add into our linked list. And then, well, we want to create a node, and then for the current node, which is temp, and we are setting the next to be the former head. Okay, so this is an interesting design because let me use this example. So previously we have the head. This head points to 93, and 93 points to 17, 17 points to 77, and 77 points to 31. Okay, that is a linked list. And if we want to do add a 26, what's the process? The first part, we want to create a new node with 26. So this is for this line of code. We create a new node, and which is temp, and this new node has a new value 26. And what's next? We are setting the temps next to the former head. And what is the former head? The former head is 93, right? So now we have 26 points to 93. And how about the head? So self head equals temp. So for the new head of this linked list, it points to 26. So let me ask you this. After we have added 26, is 26 at the very beginning of the linked list, or is 26 at the very end of the list? Okay, the answer should be, well, the 26 is at the very beginning of the linked list, and this is how we do the add. When we add a new value, we are going to add that to the very beginning of the linked list. Okay? Well, and then, well, if we want to do another one, how do we get the length? Well, for the length, well, the trick is we have to go through all the nodes in the linked list one by one in order to do a count. Okay, we are going to start from the 0, and we are going to start from the very beginning, and then we are going to start the counter as a 0. And then for the current as a reference, we want to visit all the nodes one by one, and as long as there is still next node to go, we want to move on the current cursor, and meanwhile we want to increase the count by 1, and this is how we do the count. And if the current goes to the very end, goes to the last value, and then what's the next reference? The next reference of the 31 will be a none. None means there's nothing. So if the next cursor points to nothing, and then this iteration will finish, because we have already used the current cursor to visit all the nodes. And then we want to return the count, because that is the counter of how many nodes we have touched. Okay? And here is another tricky thing I want to remind you in Python, and that is the underscore string. Well, and the reason we want to say, well, the scenario we may want to use that is, let's say we have a linked list, and then we have add 31, 77, 17, 93, and 26, and we remove one. Okay, we also remove the 93, and eventually I want to print the linked list, and I want to see all the values. I even want to do some formatting to make sure that the output is something readable. And how do I do that? And then in order to be able to do the print my list, I have to define another method called underscore string. Well, for this one, make sure that you have to assemble and return a string. Okay, well, I'm going to start from the very beginning, and that is a head hyphen. Okay, and this is the target I want to assemble. So I want to visit all the nodes one by one, and then I want to assemble such a string on the fly. Okay, I started from the head hyphen, and then I'm using the current as the cursor. I start from the very beginning, and then this is the same iteration we have done to count how many nodes do we have. And as we are visiting the nodes one by one, I want to add the current data to the string to return, and plus also a hyphen. So we are going to keep on doing that, and after we have finished visiting all the nodes, I want to do a string to return plus equals the end. Okay, so this is how we visit all the nodes one by one, and meanwhile we assemble a string on the fly, and eventually we are going to return this string to return. Okay, well, if you have a class, you want to do a print, and you want to see what is inside your object, and this is always a nice trick to implement this underscore string. Well, sometimes this can really help you debug. Okay, and there are also some linear data structures. And how about stack? Well, and when you talk about stack, well, the first thing I think about is a stack of pancake. Okay, well, say if you're making pancakes, and then you have the first one, and then where do you put the second one? The second one should be on the top, and then the third one, the fourth one. Okay, so well, if we are talking about where we can add the new values to a stack, for the stack we add values to the top. Okay, and then where do you take out values from a stack? From a stack of the pancakes, you take one from the top as well, right? So for the stack, you add to the top, and then you also take out from the top. Okay, so that's for the stack. And how about queue? So if you have a queue, you add to one side, and then you take item out from the other side. Okay, so what's the cool thing, or what is the important feature about queue? First in, first out. Okay, so we add from one side, and then we take item out from the other side, and this guarantees we have the first in, first out. And how about the stack? For the stack, if we are the first in, are we going to be the first out? No way. We are going to be the last out, right? So for the stack, it is the first in, last out. Okay, so well, this is a very quick review of some of the linear data structures in Python, and conceptually a review for the stack and the queue. Okay, I will continue in the next video.